So, hello, I'm Mohanan.
I'm Madhav, and today we're going to be looking at critical thinking in mathematics.
Yeah, that's a good thing to do because lots of people think that critical thinking is typically possible in the humanities and social sciences. In mathematics and science, people think this is not possible. So we want to show you that mathematics lends itself to critical thinking.
And fairly rigorous critical thinking.
Yeah.
So let's start with an example which is given here of a question which will come in a regular exam, but which requires no critical thinking really.
So, can a circle with radius 2 inches circumscribe an equilateral triangle with
sides
8 inches? This looks like bean, so let me write this again with and it's not bean, an equilateral triangle. Obviously the answer is no, because the triangle is much bigger.
Yeah.
Like we know it's like 2 inches and 8 inches. Yeah.
Yeah. So now let's take a question which requires a little more thinking. Not critical thinking, but just a little more thinking. Which is, can a circle whose area is 26 square centimeters?
Can a circle whose area is 26 square inches or centimeters?
Anything.
Inches.
Inches.
Since we said inches.
Since we said inches,
inches. Yeah.
Circumscribe an equilateral triangle.
Circumscribe an equilateral triangle
With whose area is 18 square inches.
Whose area is 18 square inches. Yeah. That's actually a little more challenging question.
It's a 2-3 minute question which you have to do some calculations.
Yeah. You have to find the radius of the circle
and find the side of the equilateral triangle and
from the area. Work backwards.
Yeah.
So I assume that the answer is looks like if I do the actual calculations, my guess is the answer will be again
no.
Right.
Most likely.
Okay. But anyone who has learned to calculate
should be able
basic
to
stuff. There's no critical thinking.
There's no critical thinking.
Okay.
Yeah. So now, how about if we ask the question, why do you think that this is no? The answer to this is no, and the answer to this is no. So what do you have to show in order to do that?
So suppose I write the question as, what are your reasons for answers to 1 and 2? Yes, that would
require
some thought.
Some thought.
Yeah.
So what are the important things in the first question? So there's this circle, there's radius, there's circumscribe, there's equilateral triangle.
Okay.
I'll put a thing over with the whole thing, but
right.
Yeah. And side. But
side, yeah.
So these are the concepts which we need some clarity on.
Yeah.
What do these things mean?
Yeah. Of these, I think circle and radius and equilateral triangle, I'm going to assume that most people would know. Do you think we need to go through that, or shall we just assume everybody knows?
For now, I think let's assume.
But the crucial part is actually
circumscribe.
Circumscribe. Okay, so let's write the definition of circumscribe. Circumscribe. Definition. Shall we stick to circles and triangles?
Yeah, sure.
Okay. So circle C circumscribes triangle T if and only if the textbook definition is all the
vertices.
Yeah. All the vertices of T
lie on
the periphery of the circle. Periphery of the circle. Sometimes they use circumference. Okay. Okay, so if you have a circle like this, and if you have a triangle like that, this is the vertex, this is the vertex, this is the vertex, and so all of them
are on the periphery, so this circle circumscribes this triangle.
Yeah. And I think in these cases you can show that
given this definition of circumscription, that's not possible.
This is not possible,
and this one is not
right.
Yeah.
What is the question? Is what is the vertex?
Yeah. Now that's the next question we come to. So clearly these three are vertices, right?
Right.
So usually what a vertex is defined as is when two straight lines intersect.
Mm-hmm.
Where they intersect is usually called a vertex.
So like this, if you have two straight lines intersecting, this is a vertex.
Yeah. But usually
but there is no intersection.
There's no intersection here.
So
usually, when you talk about vertices of shapes, you will say
two lines meeting.
Two lines meeting.
Yeah.
Where the point where they meet.
Okay.
Is called a vertex.
Okay. So let me write that down. Vertex. The point where two lines meet. So this is the vertex, even though there is no intersection.
Yeah.
That point that is common to both
the lines.
Lines.
Is the vertex.
Right.
Yeah.
Is it possible that there's a vertex here?
Doesn't.
In this case, this triangle is not circumscribed by.
Yeah. If there's a vertex.
If it has 4 vertices or 5 or 6 or more vertices, then the circle doesn't circumscribe
the triangle. Yeah.
Yeah.
So then what? So when we look at a vertex, so what are the so between the two lines? There's usually an angle.
An angle. Yeah. There is an angle here.
Yeah.
And there is an angle here, angle here, angle here. So what?
So this angle. So what are the different types of angles? All of us have studied these sorts of angles in school. So if we list them, so there's this which is called an acute angle, right? This one.
Acute. Yeah.
Yeah.
Acute means less than right angle.
Less than right angle. There would be a right angle.
Right. Let me. I think to make it easier for the viewers, let's say acute angle is less than a right angle.
Yeah.
And then there is right angle. Then
there is
obtuse. Yeah.
So that would look like this.
Right. Obtuse is more than a
right angle, but less than a straight angle.
Right angle, less than 2.
Less than 2 right.
Less than 2 right angles.
Yeah.
And straight angle
is
2 right angles, right?
Yeah.
And then there is a reflex angle, more than.
Yeah, that would be, say, this part of the acute angle, the larger part.
Right.
Of it.
Yeah. So, the straight angle, point to straight angle is an angle.
So this straight angle.
Right. And there is a point.
There's this. Let's mark it with a different color. That's the point where they meet. So a straight angle is an angle.
Right. So this is a straight angle.
Yeah.
But so is this.
So is that.
So is this.
So is that.
So how many straight angles does a line have?
By this it seems like the infinite number.
Infinite.
At least
so that means
geometry.
Every line has an infinite set of vertices. Let me write that down to understand this. This is actually an interesting consequence. Where do I write this? Okay. Let me write it here. Every line has an infinite set of vertices.
Yeah.
Then
the circle doesn't circumscribe.
Right, because these are all vertices all over.
Yeah.
And these vertices are not on the.
Yeah.
So.
And then you get a little bit of problem. Is this even a triangle then? What is a triangle?
Triangle is 3. You could say a triangle is a form bounded by 3 straight lines.
Okay.
So that can work.
But
right?
this is also bounded by 4 straight lines and 5 straight lines and 6 straight lines.
Okay. Right.
So if you're saying a triangle is something which is bounded by 3 straight lines,
So
and only 3.
This is a straight line.
Yeah.
This is a straight line, and these two are straight lines. So this is a quadrilateral.
Yeah.
And this is a straight line. This is a straight line. So this is a
Pentagon. And this is also an infinite-sided polygon.
That's going to create problems. Like
Yeah.
There is
So
an
this
intuition
is-
that is not the
So
case.
this is a big problem, right?
Yeah, yeah.
So now a triangle can't be an infinite-sided polygon. So let's change our definition. So what we have to do now
Yeah.
is to change our definition of what we mean by circumscription, or what we mean by meeting of two lines.
Yeah, I think what do we mean by vertex? I think
What we
do
mean
we
by
mean
vertex.
by a straight line?
Yeah.
Is look, the problem here is this, right? We're saying this is a straight line,
Yeah.
but you can think of it as being composed of two straight lines, in which case this is a vertex.
Yeah.
Suppose we have some way of avoiding that consequence.
Yes.
Right?
So how do we do that?
We'll say this is just one straight line.
Yeah.
So if we say something like if
So if one thing you can say is that two lines, the meeting point of two lines is a vertex. If and only if the point where they meet,
yeah,
a point on one of the lines and another point on this line, these 3 points are not collinear.
collinear meaning
They don't lie on the same straight line.
yeah. So this is a straight line. This is a different straight line.
Yeah.
Why can't I say that this is a straight line
Yeah.
and this is a straight line?
Yeah.
Because the whole thing is a single straight line,
Yeah.
they are not distinct straight lines.
Yeah. So they're not distinct straight lines. They're
Yeah. So if I take a straight line like this
yeah.
and put another straight line on top,
Yeah.
then they are not distinct straight
They're
lines,
not
right?
distinct straight lines.
So the whole idea would be distinct straight lines.
Yeah.
Then of course, then you have only 3 straight lines here, because
Yeah.
this straight line and this straight line are not distinct straight lines,
But
because
what-
they form a single straight line.
Yeah, because they form a distinct, but they are distinct straight lines because you would think of this. So it depends what you mean by distinct over there.
Right.
So because you could think of these two as 2 separate straight lines, or you could think of them
Yeah.
as 1 straight line.
You
So-
could say this is part of a straight line,
Yeah.
therefore they are not distinct.
Yeah.
And they are part of a straight line if you can make this into a single straight
single
line.
straight,
Right.
yeah.
So suppose I have a straight line like this,
Yeah.
and now I draw another straight line like this,
Yeah.
and the whole thing forms a single straight
Yeah.
line. Then these two are not.
So if you
distinct.
say a distinct, two straight lines are distinct, if and only if they cannot be put together to form
From a
another
single straight
single
line.
straight line.
So it's a matter of defining distinct.
Distinct.
Yeah.
Yeah.
Okay. So all the problems are solved, because then we are back to our original idea that this circle does circumscribe.
Does it solve the problem? So what is a straight line?
Oh wait. For now, the earlier problem is solved.
That
You
earlier
agree,
problem is solved.
right?
Yeah.
Now we have a new problem, because
Yeah.
we are assuming what a straight line is.
Yeah.
But for the purpose of viewers, let us say that part is solved.
Yeah. If we know what a straight line
Right.
is,
So
this part is solved.
yes.
Yeah.
So any solution gives rise to many other
Many other
problems.
problems,
That's what actually that's part
That's
of
when we
critical
talk about
thinking.
critical thinking in mind.
Okay.
Yeah.
So
So-
in that case, shall I erase all this stuff so that
Yeah.
we can now ask a different question? We assume this is done.
Yeah.
Okay. Good. At least there should be some kind of closure, at least in some parts of
Yes,
that.
a little
yeah.
bit.
Right. Not always. Yeah. Erase this as well?
Yeah. Yeah. We don't need this.
Yeah.
So by solving the last problem,
Hmm.
we came up with a new problem.
Yeah.
What is a straight line?
Is a straight line. This is not a standard question, right? No school student is going to be asked this question.
I don't think so. I haven't seen it.
So this is not a regular type question, but this is an interesting question. What is it? We can't take it for granted.
Yeah.
And I guess that is the essence of critical thinking.
Yeah.
Leave nothing for granted. When you ask this question, we are thinking critically
Yeah.
about what we take for granted. So I know, for example, that's a straight line.
Okay.
And I know this is not a straight line.
Okay.
The question is, why is this?
Makes that a straight line?
Yeah.
What makes this not a straight line?
Yeah. So supposing I said if you have 2 points A and B,
Yeah.
this is a straight line, but that is not a straight line.
Okay.
So what I need to know is why.
Why this is not a straight line, but this is.
Yeah.
So I guess one way to think about it is that this forms the shortest path between A and B, while this path will be longer.
Longer. Okay,
So
let me write that down. So A, B is a straight line. If and only if.
Yeah.
If it is the shortest path between A and B. That looks quite. Yeah, that looks obvious.
Yeah,
so
it looks
our
obvious.
problem is solved, right? Here is the answer.
What is the shortest path? So now,
Shortest path. The path that you take, if you travel a straight line from here to here, it's
so what you're saying is that the straight line is the shortest path,
Yeah.
and the shortest path is the path of the straight line.
okay. That looks like a
That
vicious
looks
cycle.
like tautology, right?
Yeah.
So
Yeah. Okay. I can't say that obviously.
yeah.
Okay.
So for the notion of shortest path, we need a concept of distance, right?
Yeah. So the distance from here to here, this path, is less than the distance, and you cannot
Have a distance less than.
draw a line such that it has less distance.
Yeah.
That's the basic intuition.
Yeah.
But what does it mean to say
Okay.
this distance is less than that distance?
Yeah.
You can't measure it.
It is mathematics. You can't take out a tape and measure. So how do we say that?
Yeah. I have heard this being said that you cannot measure the length of a line. I can, right? I can take a ruler and measure this.
But this is not a line. This is a representation of a line.
What do you mean? That is a line. I just drew a line on the green board.
Yeah, but in Euclidean geometry, which is the geometry we are in right now, a line is infinitely thin. You can't draw something in. You can't
Actually,
see it.
it says there is no.
It has no.
It has no breadth, zero breadth.
Yeah.
This has some thickness.
Yeah. Quite a bit. Yeah.
Okay, even if I draw something very thin like this, it still has some thickness.
Yeah.
So I cannot draw a line on the
Yeah.
green. Yeah.
So
okay.
this is the representation of a line. This is
Okay.
the representation of a line.
Yeah.
So this is not a line. So you can't pick up and measure something which you can't see.
Right.
Isn't that the basic rule of measurement?
So it makes no sense to say this is the shortest because this one I can see.
Yeah.
So it's not a mathematical line.
Yeah. So measuring it will not help you.
Yeah.
So now you need a concept of distance in
Yeah.
your geometry, and Euclidean geometry doesn't come with a notion of distance built into it.
Can't we say it's an undefined term that people use?
Yeah.
that, right?
Yeah. Euclid used the concept of primitive.
Primitive. Yeah. So
And-
suppose I said distance is undefined.
Yeah.
But you also have to say the idea this is shorter than that is also undefined.
Yeah.
That doesn't.
Yeah. So what Euclid actually did was he said straight lines are undefined entities,
Okay.
primitives. But,
Okay.
but yeah, we can either take distance as undefined or straight line as undefined. It's not satisfactory either of these.
Yeah.
And mathematicians now have found ways to deal with these by imposing distance on geometry.
Yeah.
But not in Euclidean. But let's assume for now we
Okay.
know what shortest path means.
Yeah.
Okay.
We really don't.
We don't,
But,
but let's assume we do.
Yeah.
Okay.
Yeah. So
And-
this is where critical thinking leads us.
Yeah.
At least it tells you where your ignorance is.
Yeah.
You have to say, since we do not know what this means,
Hmm.
we're going to take it for granted that it is intuitively obvious,
Yeah.
which it is not actually.
Yeah.
Right. Okay. Fine. I want to ask a question. Let's assume that this is a straight line and everything is
Shortest
okay
path,
in the
yeah,
world.
yeah.
Can two distinct straight lines? There was this question that somebody asked me. You know that two distinct straight lines can intersect at one point.
Hmm.
Can they intersect at two different distinct points?
No, but then that's not a straight line.
That will not be a straight line.
Yeah.
So can you have two? And I remember somebody saying, it is possible that two straight lines. It looks intuitively not obvious. It looks quite wrong. But he was saying that yes, they can, in fact.
So if we're using the intuitive notion of shortest path, let's make full use of it and say that what we mean by shortest distance is you put a pin here at A, you put a pin here at B, and stretch a string across.
Stretch a string, yeah.
And that is the...
So this will be where stretch string
is completely rigid, and that is where...
Right, but if you put two strings like that stretched, you can't have
them intersecting.
So it doesn't seem possible.
But how about on the Earth?
On the Earth?
On a sphere. So if you take put a pin on the North Pole and you put a pin on the South Pole.
Okay, so this is the Earth. Okay. And this is the North Pole and this is the South Pole.
Yeah.
And?
So, and now stretch a string. Right, these are 2 points on the
string. So here is a string, straight. Yeah.
But you can't go through the Earth, it has to go on top of the Earth.
It's on top of the Earth.
It's on top of the Earth. So now stretch another string which goes in that direction.
Like that?
Yeah.
But that's a curved line.
That looks like a curved line from here. But if you look at it on a sphere, it's not a curve.
I'm stretching it like this.
Yeah.
Slightly to the other side.
Slightly to the other side. Or let's take a simpler case. Let's take one from here to here.
Like this?
Yeah.
Okay, so there is an intersection.
Yeah. And let's take one, take it at the back also. So that, no.
So in other words, if you're saying, if you take a sphere, cut it like that, what you get is a straight line.
Cut it like that,
it's a straight line. So there are two straight lines that are intersecting at 2 points.
But this one, if you see, also, this point and this point.
If you cut it like this.
And you, like a pizza slice almost, but for a sphere.
No, if you take an apple or an orange, assume it's a sphere.
And take out a slice of an apple.
Various slices, they are all straight lines.
And it's intersecting at 2 points.
So longitudes, essentially you're saying, are all straight lines.
Yeah.
And infinitely many longitudes
intersected to go through these 2 points.
Okay. But you can't do that on a
flat surface. So that's why it's very important in mathematics to say where you're operating, the world you're operating in.
I see.
So you have to state that. We didn't, almost throughout the entire thing, we didn't say we're working Euclidean geometry, we didn't say we're working on a flat plane.
Okay. So suppose I said no two distinct straight lines can intersect or meet either at two distinct points. You're saying this is true in flat geometry, and this is false in spherical geometry.
Even in the flat case, I would like to have flat Euclidean geometry, continuous geometry.
Okay. There might be some other flat geometry where it is.
Where it's not. I don't want to take a risk and make a claim which outside. So you have to be a little careful.
So truth depends upon which world you are talking about.
Yeah.
So these are two different worlds.
Yeah.
Which is our world?
Which is our world?
Yeah. Is this true in our world, or is it false in our world? The world that we live in. Is that a flat world or a spherical world?
Mathematicians don't really care about the real world, but since you're asking that question.
Physicists do.
Physicists do.
Right. Newton's theory says
this one. And Einstein's theory says this one.
So this world, if we accept Einstein, the world that we live in is this.
Yeah.
Okay, that's that. So that's an interesting result, actually. So we were led to this result through our critical thinking. We have been thinking critically about by when we ask the question, what's a straight line?
Yeah. Actually, Einstein's geometry is not even this one, right? It's something in. It's not this. It's not this. It's.
But it's curved.
It's curved. It's not spherical.
Yeah.
But it's curved.
Curved. Yeah.
So
space is not like that. It may be just like this.
Yeah.
That's possible.
Yeah.
Okay. So when you put the sun here, space becomes like that.
Yeah.
All right. That's interesting. I want to ask another question. This again, this is something that I have struggled with. That's about the relation between circles and polygons. So if I draw a circle here And if I have a triangle that the circle circumscribes, and there is another circle inside this that the triangle circumscribes,
Yeah.
this is the distance between them. Suppose I make it into a square. There is a circle, there is a square. Oops, assume this is a square.
Yeah.
And then there is a circle inside it. The distance will be less.
Yeah.
If there is a circle and there is a pentagon, regular pentagon, let us say, and you see that the distance gets smaller. Suppose you go on increasing the sides of increasing the number of sides.
Yeah.
And these are all regular polygons. The question would be, is it possible that all of them converge into one line? So, in other words, let me put it this way, is a circle a regular polygon? This is a kind of critical thinking question, right? You have to
Think through.
deal with this carefully.
Yeah.
And you have to understand the notion circle, understand the notion polygon, and so on.
Yeah.
This question kind of intrigues me and confuses me because I seem to think, yes, it is possible. At the same time, I tend to think, no, it is not possible.
So, one way of looking at this is that keep drawing more and more
Right.
regular polygons inside this.
With more and more
More
sides.
and more sides.
Yeah.
However far you go, the side will have some length.
Yeah, so what
The
you're
length
saying
might
is that
keep decreasing.
if you keep dividing lines,
Smaller and smaller.
smaller and
bits.
smaller,
Yeah.
you can go on infinitely.
Infinitely.
So let me write that down. A line can be divided into shorter lines
As many times as you.
infinitely. You can go on, it will never stop, right?
Yeah.
So this is what Aristotle said, that if you take matter and divide it, you can keep dividing it
Yeah.
endlessly.
Yeah. So
Yeah.
here, so no matter how far you cut it, how far each line, how small each line is, the line still has some length, right? And it's not completely. Then it can't be completely curved. It can't be. It can't have no vertices, right?
Right.
A circle has no vertices.
Can a circle have vertices and still be
a circle?
Yeah. So essentially, okay, this is what the question I'm asking. Suppose this is a polygon, the side of a polygon, and this is the radius. This is the center of the circle. And the definition of circle says that that it's a set of points which are equidistant from a center. So this is this distance from here to here. This distance from here to here is the same.
Yeah. And for a regular polygon, that's also true, right?
Yeah.
You take any two sides and this distance.
So as long as there is nothing here, if there's a point here,
if there's a point here, of course, that
it
won't
will not
have the
be
same
equidistant.
distance.
Suppose you say there is no point in between, then you have a set of points that are equidistant.
Yeah.
Then the answer would be
So once again, we get into the problem of where are we living? What is the world we are inhabiting? And so if your world is points like this, with say the distance of this point from each of these points is arbitrarily 1, whatever 1 means.
Right, and there is no point in between.
There's no point in between these two. Then and a straight line is still defined in the same way, in the sense of 2 points define straight line. In that case, each of these are straight lines. Each pair of points make a straight line. And this, so then this is a polygon. If you keep going on.
Right. Then.
And so each of these is a straight line, each pair. But this thing also contains every point which is equidistant from this point.
Every point, yes. Then it'll be a circle would be a regular polygon.
In this case, a circle is a regular polygon.
So it looks like this is the one that is crucial, right? So in Euclid, any finite line has infinitely many points. That's what gives you this. You can keep dividing it endlessly. Supposing I said, instead of that, supposing I said any finite line has finite number of points.
In that case, there might be circle.
At some point, you cannot divide it any further,
Yeah.
right?
So then, in that case, there might be
Yeah.
circles which are regular polygons. And
Right.
there might be situations where they are.
But that will not be Euclidean world.
Yeah, that's not the
Yeah.
Euclidean world.
So this is what Aristotle said about matter, and Democritus said that if you keep dividing matter,
At some point, you reach.
you get an indivisible particle, and suppose you say a point is like indivisible particle. You cannot go any further.
Yeah.
So there can be two such particles
Yeah.
that would constitute a line. You divide it, you get a point, not a line.
Yeah.
So this is
Yeah.
that's Democritus geography, Democritus geometry.
No, you're not going to name a mathematical theory after a physicist.
Okay.
This is Euclidean, not Aristotelian.
Well, but if you say this is Aristotelian,
Yeah,
this
then
is
this is
Democritus.
Democritus.
Okay. So in that world, in Democritus geometry,
Yeah.
a circle is a regular polygon, where
in some parts of, in some types of in some types of what is called discrete geometry, Democritus.
so if you say there exist lines which have exactly 2 points.
Yeah.
So there is no point in between.
Yeah.
So I could have a straight line. This is a straight line. Straight
but,
line with
but
2
if
points.
but if you only had 3 points in your world, then you don't have a circle which is a regular polygon because there's no such thing as a polygon in this world. So
okay.
that's why I'm
Okay.
being a little careful on.
Okay. So critical thinking means being very, very careful.
very careful.
Okay.
So
All right.
it's important to.
Okay. All right. Since we're talking about, I'm having great fun here. You talked about spherical geometry. So again, this was a question that somebody asked me. We are told that a triangle has the sum of angles in a triangle is 2 right angles. And somebody said, why can't it be 3 right angles? And I sort of thought. It didn't make any sense to me.
Okay.
So is that possible for a triangle to have 3 right angles?
So let's go back to the sphere.
Yeah.
So try and cut a chunk out of the sphere, which is something of this sort.
Wait. I think there's too much stuff on the board, so I'm going to erase this. I like clean occasionally. Yeah. Okay. Chunks like that?
But what I mean is that you cut it into a piece downwards
So
like this.
here is an apple,
Yeah. So cut
and
it.
you cut it like this.
Yeah. And then
Okay.
cut it like this.
Cut it like this.
Yeah. And now cut it downwards also.
Okay. So let me say I cut it like that,
Yeah.
and then I cut it like this, and I cut it like this. So that's what you drew there.
Yeah.
This
Yeah.
this is what you mean.
Yeah.
So these are all curved lines.
Yeah.
This is not a straight line.
This is not a straight line. So now we have to figure out what you mean by angle, right?
No, but a triangle should be bounded by straight lines.
Oh, but isn't this a straight line?
No,
What
this
was the
is-
definition of a straight line?
This is, look at this.
Hmm.
This is curved.
What's a straight line? Let's stick to the definition. The straight line is the
if you
shortest path.
If you stretch,
I
I forgot that. If
Yeah.
you stretch this like that, if you stretch it like this, okay.
Yeah.
It looks curved because we are
because
drawing a
you're-
picture on the blackboard.
Yeah, and also, and you're putting your own.
Yeah, right. I shouldn't do that. Okay.
So now, to say that this is a right angle. If you want to say that this is a right angle, what do you mean by that? What do you mean by this being a right angle in spherical geometry?
Right angle means, right, independently of spherical geometry,
yeah.
you can say if you have 2 lines meeting at this point,
Yeah.
and this angle is equal to this angle,
Yeah.
then these 2 are right angles.
Yeah.
That's the normal.
Yeah.
I see.
So this line and this line meet, and this breaks it into
this
two.
breaks
This
it
angle
into
is
2,
equal.
so this is the right
This
angle.
is a right angle. Similarly, this is a right angle.
Right angle. And these 2 also.
These two also the same.
It
thing.
doesn't look like
It
that,
yeah.
but you're cutting it like
the
this.
same. Yeah.
This is the right angle.
Yeah. If you look at it from the top, you'll see that
Yeah,
this
it's
is
a
also
right
a
angle.
right angle.
So there are 3 right angles.
Yeah.
So in spherical geometry, you're saying there can be 3
Three right angles.
in a straight,
in a
triangle, but not in Euclidean geometry.
Not really.
So once again,
Yeah.
the answer depends upon which
World
we are
you're
talking
living.
about. All this is okay. I don't think I can take any more. My head is all spinning. So maybe we could talk about other things of this kind later, but not today. Today I'm completely full. My head is full. So let's go have some coffee.
Yes.
Okay.
Okay.